Hi, I'm John Quick with Dynaudio North America, and I'm here at Audio High in Mountain View, California, right in the heart of Silicon Valley. We're here today to do a training on our various lines. Audio High is currently showing our confidence range, our contour range, our adaptive focus range, our evoke range. So we were optimizing some of the speaker placements, and we're doing a little training on some things that make Dynaudio special. So we thought it would be useful to elaborate on some of those for you as well. One of the very consistent things about a Dynaudio product is the choice of materials. And since the very early 1980s, we've used two primary technologies that make Dynaudio speakers sound consistent from generation to generation, and also consistent from range to range within any given time frame. One of the overarching goals of a Dynaudio loudspeaker is to produce natural sound with low listening fatigue that sounds very natural and neutral. And we employ a number of different technologies to bring that to you. And part of it has to do with materials, and part of it has to do with some of the ways we engineer our drivers and our crossovers. On the material side, there are two things that have been consistent since the early 1980s with Dynaudio. One of them is called MSP, which stands for magnesium silicate polymer. We employ this in our mid-ranges and our woofers. And the second are soft dome tweeters, which have been the hallmark of Dynaudio, again, since the very early 1980s. So in addition to producing neutral, accurate sound, one of the other things that's very important to us is to be able to play loudly without compression or listener fatigue. In order to do that, you need good engineering and you need good solid driver technology, but you also need things that make the drivers reliable. And this cone with attached voice coil will serve pretty well to explain. For one, the adhesion point between the voice coil former and the cone itself is helped out quite a bit by dimples that are engineered into the rear of the cone, which provide additional contact points and allow it to be more rigid, but also prohibit one of the two primary failure points in a dynamic driver, which is detachment of the voice coil from the driver diaphragm itself. So in addition to aiming for ultimate performance, low listening fatigue, neutrality, the hallmark of a Dynaudio speaker, what's also very important to us is low dynamic compression and reliability. So those two things actually coincide pretty well in engineering. Reducing heat and reducing weight are two things we try to do in all of our drivers. And in the case of the newest generation drivers, we've done two things that are new. We actually are using a fiberglass voice coil former. So the former is what the wire is wound on. This is called the voice coil, which is the wire, and the former is what it's wound on. Typically they're made out of aluminum or titanium, or in some cases Kapton. So the reason we use fiberglass for the voice coil former, so the former is actually what the voice coil is wound on. There are three reasons we use the fiberglass. Number one, consistency. The material actually lends itself very well to staying in round. We make thousands of drivers a year, and consistency of the material is very, very important. Secondly, it doesn't have any magnetic properties. Even though aluminum, titanium, they're not as conductive as, say, copper, they do actually produce eddy currents when they run through the magnetic field of the magnet of the motor of the driver. Fiberglass does not. Thirdly, fiberglass actually can be perforated without structural integrity losses. So these holes that you see here between the cone and this is what's called the spider. So this is the basis of our tweeter diaphragm. As you can see, it's a very open mesh. This on its own can't push any air. The finished product is coated with what we call DSR, for Dynaudio Secret Recipe. This material seals all the holes in the very light silk dome.